One more thing here quick. So it's, the equation's true. This is always how we calculate the force of gravity. It's a little weird to think about, though, calculating the force of gravity for something this way and thinking of g as the free fall acceleration due to gravity if the object's not actually in free fall. But we know if an object is sitting on the Earth, it still has a force of gravity pulling down on it, like this problem we did earlier in the question of the day. There was still this force of gravity pulling down on the object. And so this is still the equation for the force of gravity, even if it's not in free fall. And to make sense of that, there's a different way we can think of g. And so the other way to think of the force of gravity is it's still m times g. But another way to think of this, and a way this is sometimes referred to, is as what's called the gravitational field strength. Which is 9.8. But instead of writing it as meters per second squared, remember a newton is the same thing as a kilogram meter per second squared. And so if we write this as 9.8 newtons, that's just like this, except it's got an extra kilogram. Okay, so that's a newton. And so if we want to just get it to be meters per second squared, if we just divide by kilograms, a newton per kilogram has got to be the same thing as a meter per second squared. And so we can think of g as being not necessarily 9.8 meters per second squared, which is weird when the object's not actually accelerating, right? But this is true no matter what. If you're sitting on the surface of some planet or anywhere near the planet, the force of gravity from the planet is going to pull down with a certain number of newtons of force, and the number of newtons of force it pulls with depends on your mass, because we said the force of gravity changes based on the mass of the object, has this direct relationship. So if you have 3 times as much mass, you get 3 times as much force of gravity. We can see this from the equation, and that's what's going on here. For every kilogram of mass, you get 9.8 newtons of force of gravity.